a triangle, a trapezoid, and then kites and rhombi. When I said those, could you think of the formula? Hey, I'm going to tell you, when in doubt, when they say write the formula down, if you have no clue, write B times H. Okay? It's going to come and help you out. So the area of the circle gets confused a lot with the circumference of the circle. So first off, what's the difference? What's the circumference of the circle? All the way around the outside. What's the area of the circle? Inside, right? So this is where you got to differentiate. When we did the circumference of the circle, my formula was what? 2 pi r or pi d. For whatever reason, everybody loves the formula for the area of the circle, though. And they try to use that sometimes with the circumference. So my area, remember, capital A, got to be capital A, is what? Pi what? Thank you. So big difference between pi r squared and 2 pi r, right? 2 pi r means 2 times the r. What does r squared mean? R times itself, right? So again, doesn't matter what form of pi that I use. I can use the button, I can use 3.14, I can use 22/7. All of that should get you the right answer. Again, while you're doing these problems, do not round until the very, very end. Okay? Do not round until the very, very end. All right? So again, now, if they give you a diameter instead of a radius, the first thing that I have to do is what? Divide by 2, right? You got to divide by 2. Okay? So you got to keep that in mind also. You're going to like this section. So notice this one right here. Might have to draw a circle around polygons to help you figure out the problems. So remember that. Because if I know I can find the area of my circle, I can look inside if I can fit it like a rectangle in there or something. And then I can use that information and subtract it out. So again, hopefully this isn't real complicated. We'll come back and look at a couple of examples of this, but that's basically all we're going to say about that. Okay? So the next part is, which is probably kind of more of an introduction in this section, is the area of a sector of a circle. What's that mean to you? What's a sector mean? Yeah, a part of it, right? Okay? So, when you're doing the area of a sector, you're going to have your circle, you're going to have your center, and then you're going to draw this, which is called a central angle, right? So what's the relationship that's important with the central angle? The arc is exactly the same as the angle, exactly right. And the arc that we're talking about is the intercepted arc, or that one right there, right? The arc that's inside of my angle. And the degree measure is the same degree measure as the two, as Kenzie said. So the angle and the arc are the same. Now what happens if they don't tell me this? Can I find this angle if they just show me the different pieces? Yeah, because if they tell me that they have equal pieces, then I can just divide the equal number of pieces by 360, and that'll tell me each degree of that. That makes sense what I'm saying there? So if I were to split my, I don't know if those are equal. No, they're really not. But let's just say they are. Okay? And I would have 3. Then each one of these would be how much? What's 360 divided by 3? 120. So each one of these would be 120. So each arc would also be 120. So keep that in mind. Okay? So this leads us to our formula of the area of a sector. So again, capital A. And here maybe you say it's the area of a sector. You don't have to do this, but just so you differentiate between the two. So basically we're doing a portion of the whole circle, right? I'm basically trying to do this little section right in here. This whole thing. So let's erase this one. And I'm trying to do that one right there. Okay? Everybody agree with what I'm saying? So I'm taking a portion of the overall circle and I'm trying to find out what I have the area for that as. All right, so it's a portion of it. So I'm still going to have my pi r squared because I still have to have the entire circle. But I just want a portion of it. And so we're going to take x degrees. So again now, because we say that this is x degrees, this is actually our central angle. And what do we base the whole thing off of? 360 degrees. So we're going to take x divided by 360 degrees to find out what portion of the whole circle that I have. That makes sense? And again, this is just all multiplied together. So basically, if you wanted to do this, you can take x times pi times r squared divided by 360. Essentially, you can divide by 360 whenever you want. But again, remember, it's r squared and not 2r. Any questions here? That's it for today. Okay? What? I didn't hear what you said.
It's not anymore.
All right, here's my circle. So an outdoor accessories company manufactures circular covers for outdoor umbrellas. So the most important part of this problem is what? What's that? Yeah, there's two circles, right? If the cover is 8 inches longer than the umbrella on each side, find the area of the cover in square inches. So again, make sure, this is huge, that your labels are the same. It says to answer it in square inches, but they give me inches, so I'm good. But if they gave me feet, and they ask me to do it in inches or vice versa, then you have to do some conversions. Okay? That's what you had to do on a couple of those problems today. All right, so what am I going to use when I'm doing my R in this? If 72 is the diameter of the littler circle, what is my radius of the entire cover? How much? Okay, but I want the radius, so then I divide by 2. Did everybody hear what Bo said? Okay, or I can just think about, I'm going to take 72 and divide by 2, which is 36, and then add my 8. Either way, you're going to get what Bo got, which is 44, right? So I'm going to take 44 and punch it into my calculator. But remember, pi r squared, so I take 44 and square it, and then multiply it by pi. That's huge. So we get 6,082.1, and then don't forget that we always need a label. Holy cow, people. Square inches. Remember, it's got to be inches, and then put your little square on it because I multiplied two things together instead of just added them together. Okay? And again, this book's famous for rounding. Don't round. At least go to 1 or 2 decimal places, unless it specifically says in the directions. Okay? That makes sense to everybody? So basically now we're going to go backwards in this one. Find the radius of a circle with an area of 45 square inches. So what are we going to do? Basically we're just going backwards, right? 45 equals what? Pi r squared. So how do I figure this one out? Divide by pi and then take the square root. Exactly right. Everybody good? Now, what's my label? Just inches, right? Because I'm looking for the radius now instead of the area. Make sense? So here's my sector, right? So again, if you want to look at this, this is my sector. I'm looking for that central angle. All right? It's just an example of that. A pie has a diameter of 9 inches and is cut into 10 congruent slices. What is the area of one slice to the nearest 100? Everybody understand what we're doing? So what is my central angle for this problem? How much? 36, exactly right. Because why? Because they said there are 10 congruent slices, right? So I'm taking 360 divided by 10. So as a sense, my x is 36, and I'm going to take 36 divided by 360, but that gave me it as the what? The diameter, so what do I have to do to 9 inches? Divided by 2. So my formula here would have been 36 over 360 times pi 4.5 squared. Everybody understand how you're going to punch that in your calculator? Okay, so again, if you want to wait and divide by 360 at the very end, that's totally fine. If you want to do it right away, that's totally fine. Just do not drop off your decimal places. If you do this division right here, 360 or 36 divided by 360, do not drop your decimal places off. Okay? All right with that? So we get 6.36 inches squared. I think that's it. Yeah. So if they don't say congruent slices, then you have to just be able to figure it out. You might be given like something like this. So if you're given a circle and they're asking you that this is X degrees, but then they told you that this part over here was, I don't know, 280 degrees. If that arc is 280 degrees, can I find what this is? Yeah, because these two should be the same, and so I'm just going to take 360 minus 280 and get that little section there. So that should be a couple of problems that you have to do. All right? Don't forget your label. I don't care what you use for pi. That should be about it. Questions here? Hopefully this section's not too demanding, right? So the assignment will come up here. Let's correct your other two assignments at 5 till. So if you have questions, now you got 7 minutes to ask questions. So again, just the bottom ones if you want, or if you have to do. If you want to do more, do more.